Assalamualaikum everyone. I'm Soda Farihan Noor. I will be presenting our research titled Comparative Analysis of Hydrokinetic Energy, Photovoltaic and Diesel Generator Systems for Sustainable Rural Electrification. This work conducted under the Sustainable Energy and Power Electronics Research Group at University Malaysia, Pahang. We aim to identify the most viable solution for powering rural areas using renewable and hybrid energy technologies. Let's begin. Electricity access plays a vital role in improving healthcare, education, water supply, and overall economic development. Yet, in many developing regions, including parts of Malaysia, electrifying remote areas remains a huge challenge. Extending the central grid to such locations is technically difficult and economically unfeasible. As a result, diesel generators are commonly used due to their reliability. However, they come with a significant environmental and cost-related downsides. On the other hand, renewable options, especially solar and hydrokinetic energy, have gained attention due to the technological improvements and decreasing costs. In this context, our study compares these three systems using the Homer Pro simulation tool to identify the most balanced solution for rural electrification in Malaysia. To ensure a meaningful analysis, we selected a specific site, Sungai Pahang at Lubuk Paku, which is riverine region with a favorable water flow and solar radiation. Using Homer Pro, we modeled three distinct energy systems. The hydrokinetic system used a smart monoflow turbine rated at 5 kilowatt. The photovoltaic system included 15 kilowatt of solar panels with storage batteries, and finally, a conventional 10 kilowatt diesel generator system served as a benchmark for comparison. All systems were designed to meet the annual electricity demand of typical smaller rural communities, estimated at 1245 kilowatt hours per year. This table summarizes key configuration and financial details for the three systems. Hydrokinetic systems require a high upfront investment per kilowatt due to specialized turbines and infrastructure. However, they benefit from zero fuel costs, lower operating expenses. The photovoltaic system have moderate capital cost but still depends on costly battery storage and solar irradiance viability. Diesel generators are cheaper to install initially but incur ongoing fuel and maintenance costs which increase over time due to fuel price volatility and wear and tear. All systems were accessed over 25-year project lifespan, which is standard for a renewable installations. When we analyze the economic feasibility of such systems, the hydrokinetic system clearly outperformed the others. It had lowest net present cost at 4,78,562 ringgit and the most affordable levelized cost of energy or LCOE at 2.52 per kilowatt hour RF. In contrast, the photovoltaic system, through clean and modular, incurred the highest capital and storage costs, resulting in an LCOE of 6.37 per kilowatt hour ringgit, more than double that of hydrokinetic. The diesel system offered a middle ground with a moderate NPC, but its LCOE of RM 3.91 is still significantly higher than hydrokinetic, and it's highly sensitive to the rising fuel costs. Over the long term, the economic instability makes it a less attractive option. In terms of technical output, the hydrokinetic system again leads the highest energy production, about 38,000 kilowatt hours per year, far exceeding communities' demand. However, this also resulted in large surplus of excess electricity, suggesting that energy could be either stored, shared, or the load increased to improve utilization. The photovoltaic system generated around 26,000 kilowatt per hour annually, but had a higher unmet load due to intermittency and limitations in battery storage. The diesel generators produced slightly less 22,540 kilowatt hour, but interestingly had zero unmet load. The reliability makes diesel attractive, especially when energy needs are constant, but again, this comes at the other trade-offs as we will see next. One of the strongest arguments in favor of renewable system in the environmental benefit, both hydrokinetic and photovoltaic systems operate with zero direct carbon emissions throughout their lifetime. In contrast, the diesel generator system emitted nearly 28,000 kilograms of carbon dioxide per year, along with other harmful pollutants such as carbon monoxide and nitrogen dioxide. Diesel systems also generate noise pollution depend on an extensive fossil fuel supply chain that includes extraction, refining, and transport, all of which contribute to ecological degradation. In remote communities where agriculture and nature are intertwined with livelihood, maintaining environmental integrity is just as important as supplying electricity. To conclude, hydrokinetic energy offers the best balance of cost, performance, and environmental sustainability, particularly for locations near rivers and streams, where photovoltaic system is emission free, its high cost and dependency on sunlight is limit its utility. Diesel remains reliable but carries high long-term costs and environmental penalties. These findings can guide policymakers and engineers in selecting appropriate technologies for rural electrification. We extend our sincere thanks to University of Malaysia Pahang Al Sultan Abdullah for their support through internal grants. Thank you for your attention. We now welcome any questions or feedback you may have.